Okay. So good morning everyone. Today let us try to discuss the second year physics formulas. So as usual, open your notebooks. Make sure that you write the formula and check whether you are getting it right or not. So today let us try to revise. So good morning everyone. So people who are live on YouTube, please open your notebooks. Try to write the formula and check whether you are getting it right or not. Don't just watch it like a movie. Okay? This is just a kind of revision session so that this will be the last chance for you to check whether you are getting it right or not. So good morning everyone. We have Vamshi, Nani and all. So let's try to start our session. So before getting into the session, so we have discussed first year formulas as well yesterday. So please try to watch in the playlist. We have first year formulas we discussed yesterday, those who are new today. So now let us start with our second year physics formulas. So before getting into the second year, yesterday we missed a small topic in first year, that is hydrostatics, hydrodynamics and statics. So try to write the formulas that you know. So good morning. So good morning everyone. So try to write the all formulas that you know about hydrodynamics and statics. See, I'm trying to give you a blank space so that you will complete it, so that you can check whether you are getting it right or not at the end. So try to fill in the blanks. So here a vessel filled with water moving with an acceleration a along positive x-axis. So then the value of tan theta, here a U-tube with water and is revolving around one of its axis with angular velocity omega. Try to find the formula for delta H. So try to fill the blanks. Yes, Mr. Shiva, yes, we can expect minimum 1 to 2 formulas from density concept. Good morning. Good morning to Sham. Good morning to Nani. Come on, try to fill in the blanks. Reply in the chat so that let's try to keep it as engaging as possible. Try to write the formulas and check whether you are getting it right or wrong. So how do you define relative density? Density of a substance by density of water, right? So what is Pascal's law? See, let us so how do you okay, so how do you define Pascal's law? See, pressure within the liquid is same at every point, even it is same at position 1 and position 2. So F1 by A1 is equal to F2 by A2. So hope you are writing it. So try to reply in the chat box. Now let us try to look at the formula for tan theta for a measuring bar for a which is moving with an acceleration a, which makes an angle theta. Try to find the formula for tan theta. So these are standard questions that we can expect in any competitive exam. So you need to be aware of this. So what is this? What is the value of tan theta? You come here. Third bench, it is right. Please be seated. It is nothing but a by g, where is the acceleration towards along the x-axis and g is the acceleration due to gravity. How about this delta h, where h1 is the height of the column on the left side and h2 is the height of the column on the right side. So come on, people watching on YouTube, try to reply on chat box so that we can make this session more engaging. So these are the basic fundamental formulas. If you try to look at hydrostatics and dynamics. Let us still move forward. Hope you have written, copied. So what is the now try to reply the formula. Yes, Ramesh, we will be getting into second year once we are done with this topic. Actually, yesterday we missed the topic as time was the constraint. Okay. So what is the formula? Reply in chat box. Height h in terms of omega, where r is the radius of the measuring jar. Okay, anyone? You please be seated in there. Why are you sitting last bench? You can also write it as v square by 2g, right? So actually yesterday we missed this topic, so we are trying to cover it. This belongs to first year. Once we are done, we will be getting into second year. No worries. So then what is Archimedes principle? So please try to write in your notes what is Archimedes principle. Hope this question is a part of your IPE syllabus as well. So please do reply in chat box. What is Archimedes principle? People watching YouTube live, make this session more engaging, okay? So once we are done with this, we will be into second year physics. No worries. So what is Archimedes principle? What does it say? Weight of let me keep it in simple words. When you try to immerse a body in any given fluid, let us consider it the fluid of density rho, the amount of upward force that is being acted upon the body is equal to nothing but buoyancy force, which is equal to the weight of volume of liquid displaced. Okay, the upward force that is being acted upon a body immersed in a liquid is equal to the weight of volume of liquid displaced. So Mr. Gamer, follow the formulas, nothing to worry. So okay, Harsha, buoyancy force, right? So how do you represent apparent weight? In exam you will be asked direct question. What do you mean by apparent weight? When a body is liquid, when a body is immersed in a liquid, what do you mean by apparent weight? It is nothing but true weight minus upward thrust. Apparent weight is equal to true weight minus upward thrust. What do you mean by upward thrust? Nothing but the weight of volume of liquid displaced according to our Archimedes principle. Okay. Now let us try to go to our favorite principle, Bernoulli's principle. So what does it say? Try to write the equation for Bernoulli's principle. So come on, people watching online, try to write the Bernoulli's principle and check whether you are getting it right or wrong. So P by rho g plus V square by 2g plus Z is equal to constant. So this is the Bernoulli's principle. What does this represent? What does P by rho g represent? This is part of properties of fluid from first year. Once we are done, we will be getting into second year. Actually, we missed it due to time constraint. So this syllabus is a part of eamcet, bitsat, mains, NEET, whatnot. You can expect questions from these from any exam. So try to revise your basic concepts. So what does P by rho g represent? P by rho g, which form of energy? This pressure head. How about this? Velocity head. This is normal height that you know. So which principle does this Bernoulli's follow? It follows the law of conservation of energy. Yes, definitely the maths and chemistry classes will be followed, so no worries. Yes. So this is law of conservation of energy. People who are watching online, if you want first year entire physics, you can look at playlists. In the quick revision playlist, we have entire first year physics. Today we are about to start second year physics once we are done. Okay. So we have Rakshita, yes, she's read law of conservation of energy. So now let us try to look at so I will be giving you blanks, try to fill them. So try to fill all these. So try to fill those equations, people watching online. Okay, we have Akanksha, she is right. Okay, still, how about the other two formulas? Try to fill them, make the session as interactive as possible. Come on, people watching online, try to interact, try to check whether you are getting it right or wrong. Okay, what is this formula? Under root 2gh. What does h stand for? This is capital H minus small h. So what is this range? Two under root h into capital H minus small h. So if I want to write it more clearly, 2 under root h into capital H minus small h. So what is flow rate? Area into velocity. So the area of orifice into V under root 2g capital H minus small h. Okay. Okay, Bharat, we are trying to do the same. We are trying to revise the formula. So it is not 4. Okay, yes, Akanksha, you are right again. Now let us try to discuss some basic concepts between the fluid friction and solid friction. So what is the fundamental basic difference between the fluid friction and solid friction? One point that basically differentiates fluid friction and solid friction, if we can recall. Does solid friction depends on area of contact? So my question is, does solid friction depends on area of contact? Depends or not? How about fluid friction? Does fluid friction depends on area of contact? See, the direct question will be asked in your BITSAT exam. I guess it is +3 minus 1 or +4 minus 1? +3 minus 1, right? So direct question, you can answer in 10 seconds. Basic fundamental question. Does solid friction depends on area of contact? Solid friction is independent of area of contact. Which means it does not depend on area. Whereas fluid friction depends on area. The famous formula for fluid friction, can you recall what is the famous formula for fluid friction? Come on, people watching online, there are good number of people. Try to reply on chat. So the famous Newton's law of friction, F is equal to mu A du by dy, where u is the rate of change of velocity with respect to y distance, a is the area of contact, mu is the coefficient of friction. So if you try to write this way, it will be tau is equal to mu du by dy, where tau is the shear stress developed. Okay. So the next point is solid friction. Does solid friction depends on relative velocity or not? Does solid friction depends on relative velocity? Yes or no? See, same direct question, basic fundamental concepts you will be checked. Does solid friction depends on relative velocity between the two surfaces? Now, as solid friction does not depend on the relative velocity. How about this fluid friction? Will it depend on relative velocity or not? Yes, it depends on relative velocity. We can make out from this equation. Depends on relative velocity. Yes, okay. So now finally we have one last equation here, that is Stokes' law. I guess this will be the last equation from first year physics. So we will be getting into second year physics once we are done. So Mr. Srikanth, good morning. Try to fill the blank. What is Stokes' law and check whether you are right or wrong. So people watching online, please do like and share the session so that your friends get benefited. We are putting lot of efforts and providing it for free. So your likes really encourage us. So do like. We are about to get into the second year physics. So like and share the session. Subscribe to our Roots Academy channel so that you can get updates. So hi Harsha, come on. So what is Stokes' law? What is Stokes' law? What does it tell about? It tries to talk about terminal velocity. So what is the formula for terminal velocity? Two by 9 r square g where mu is the coefficient of friction, density of object and density of liquid, r square is the radius of object, g is the acceleration due to gravity, and we can make out from that. So Mr. Harish, hi. So try to reply. So this will be the last equation for our first year. 2. 9. See, you are about to write exam and asking whether it is 2 or not. Which one? This one? Alpha. Looking like alpha. See, this is alpha. Okay, now let us get into second year physics, as our session is for that. So people, okay, Mr. Chaser, hi. So now let us get back to our second year physics. So the first topic in second year physics, waves. So as we are running short of time, let us try to cover as many important as possible. So try to write the formulas that you know about waves. So come on, people in chat box, reply. Try to write formulas that you know about weights, about waves. So please do share the session so that most of your friends get benefited. Like the session and subscribe to the channel. So we are putting lot of efforts and providing it for free. So your likes really encourage us. So hi Balaji, come on, do like. Your likes will provoke us to do as many videos as possible. So finally you get benefited. So make sure that you get most out of our session. So try to fill in the blank. Time period. So the wave of speed of wave. Speed when m comma t given in terms of m and t. Velocity of wave in terms of m and t. So now interference. Interference of two waves. When two waves interfere, what is the resultant amplitude? Considering A1 and A2 are the amplitudes of and with a phase difference of delta. So come on, try to, what is time period? Fill these three blanks. Come on, yes, we have Akanksha, you are right. Come on, yes, we will be discussing open pipe and all. Yes, definitely, Latha, we are doing the same, we are trying to do the same. Come on, try to fill out the remaining blanks. These questions, these fundamentals get repeated in almost every competitive exam. Yes, Rakshita, you are right. Still, another versions of time period. There are many other versions, right? So what is time period? 2 pi by omega. 2 pi f. Okay? You can write in many forms. So what is this speed in terms of tension and linear density? Under root of T by mu. Okay, nothing but M. So what is this interference? What is M here? M is not just mass, it is linear density. Okay, we can write it as mu as well. So what is this resultant interference when the phase difference between them is delta? It gives us under root of a1 square plus a2 square plus 2a1 a2 cos delta. So the resultant interference. Now let us try to look at some conditions, okay? Yes, Mr. Vardhan. So come on, let us try to, okay, Dream Chaser, you are doing good. Now let us try to take the particular conditions. String fixed at both ends. Now we are trying to speed up the process, so try to be fast. So now conditions for spring fixed at both ends, try to write them. What are the boundary conditions? Okay, try to fill it. Next, how do you write frequency? Relation for frequency. Fundamental frequency, first fundamental frequency. Or first harmonics. Try to fill out the blanks and check whether you are getting them right or wrong. Second, third, in the similar fashion, second, third, so come on people watching online, reply, get engaged in the session. We have 4 to 5 blanks. Try to fill them and check whether you are right or wrong. So share the session with your friends so that they get benefited. And like this session as well, it really boosts our confidence and energy. So it will motivate us to do more sessions and give it for free. So putting such efforts in the last minute is not an easy job when we are only doing it for you. So encourage us by your likes, shares. So come on, reply it in the chat box. So what are boundary conditions? See, how does the diagram look like? See, when string is fixed at both ends, this will be the condition, right? So let me take so at x equal to 0, what is y? And at x equal to L, what is y? These are boundary conditions, okay? So what is y at x equal to 0? Y is nothing but amplitude, 0. Same is the case with here. So these two are boundary conditions. So how do you write frequency? N by 12 under root T by mu, where mu is the linear density, T is the tension, N is the number of harmonics, first or second or third, and L is the length of the string. So if you try to apply the here, it will be 1 by 12 under root T by mu. See, these questions you will directly get in many competitive exams. What is second? 2 times. In the similar fashion, what is third? Replace n equal to 3. Replace n equal to 2. Okay. So people are asking to speed up. I guess you are doing. Hope you have completed. So let us try to. Okay, as people are asking us to speed up, even let us try to move as fast as possible. Okay, string fixed at one end. So what are the conditions? What is first harmonics? Try to write formulas for it. Second, third, fourth. Try to write formulas for it. String fixed at one end. Whose length is L. Come on, people watching online, try to reply on chat box. We are trying to do it fast according to your request. So what is the boundary conditions at first sight when x equal to 0, y equal to 0, right? So what is first harmonics? Formula for first harmonics nothing but fundamental frequency. For L still T by mu. Okay. How about second? See, there won't be second harmonics and fourth harmonics. Only 1, 3, 5. Okay. For a spring fixed at one end, only odd harmonics are present. It will be 3 by 4L under root of T by mu. And in the similar fashion, if you go for fifth, it will be 5 by 4L under root of T by mu. Okay. So there won't be second and fourth. Okay, definitely. Let's try to speed up as per people on YouTube request. We are trying to speed up. Okay, chalo, chalo. Now let us get back to sound waves. Okay. Sound waves. Okay, right. See, velocity of sound. Formula for velocity of sound in liquid, solid and gas. Okay. Solid, liquid and gas. Try to fill in the blank. We are trying to speed up as per request on YouTube. Come on. We are not trying to lag. Hi Gayatri, come on. Try to fill the blank. Okay, we are trying to speed up. Okay, Mr. Akshay, as per your request. Okay, come on, fill in the blank. So velocity of sound in solid, formula for velocity of sound in solid, liquid and gas. Come on. So hi everyone, good morning. Try to fill in the blank. People watching online, come on. Okay, Lata, come on. Still. So let us try to speed up. So velocity of sound in solid under root y by rho. Velocity of sound in liquid under root b by rho. Velocity of sound in gas under root gamma p by rho. Where p is the pressure, rho is the density, b is the bulk modulus, y is the Young's modulus. Still, how all can you write this? Right? For a where n is equal to 1 for 1 mole. Okay, now let us try to look at the another important concept in sound wave. This is the about velocity of sound. Now let us try to look at Doppler effect. Okay, very important. Try to write the formula for Doppler effect. Come on. So people watching online, okay, see, we are trying to cover Doppler effect because it is a part of any competitive exam that you are going to write. Okay, so we are trying to cover BITSAT, JEE mains, advanced as well. So try to learn. Okay. Okay. Come on, people online. What does Doppler effects talks about? It talks about velocity. So what are these notations stand for? What does this is frequency, right? Frequency of sound is equal to V plus U naught by V minus U naught into initial frequency. So V is the velocity of sound in medium, U naught is the velocity of observer. In a similar fashion, this is the initial frequency and this is final frequency. Okay, now we are trying to speed up, we are trying to jump between concept as people are requesting to speed up. Come on, speed up. Okay, chalo. Next, let us try to look at light waves. Let us try to look at light waves. Even here we have a famous experiment, YDSC. What is YDSC stands for? Okay. What do we find in this? Why do we do this experiment? What is the objective? What do we find? Okay, Okay, Aditya, dream chasers, you are right. So what is the objective? Why do we do this experiment for? What for what? So I'll try to give you blanks, try to fill them. So try to fill these blanks using YDSC, Young's double slit experiment, using these notations where D is the distance between two sources, capital A is the distance between the source and the screen, and theta is the angle made. Okay, so find the path difference. Come on, people watching online. Okay, Gayatri, okay. Okay, Lata, right. Okay, dream chaser, okay. Come on, try to fill all those blanks. Come on, people watching online, please do like and share the session with your friends so that most of them get benefited. So your likes really encourage us and makes us do more and more such videos and give it for free. Okay, we are putting lot of efforts and it's not an easy job. So encourage us with your likes, share the session. Okay, people watching online, get engaged. Okay, come on, share the session. And for updates, subscribe to the Roots Academy. The maths and chemistry classes will follow. See, what is this path difference? This is dy by d, okay. What is this phase difference? 2 pi by lambda delta x. Okay. What is this delta x? Path difference. So how do you find the resultant intensity? So people watching online, get engaged, try to comment. What is the resultant intensity? I1 plus I2 plus 2 under root I1 I2 cos delta. So what is the maximum? Formula for maximum intensity possible. So people watching online, come on, dream chaser, okay. So what is the Imax? Under root of I1 plus under root of I2 whole square. In the similar fashion, if you replace this with I minimum, you will have minus for I minimum. Hope this is clear with you. Try to write, try to copy, man. उसमें explain करने का ज़रूरत नहीं है. देखते ही मालूम होना आपको. Come on. So now we are getting to or switching to optics. Now let us go to optics. So I am trying to give you the blank. Try to fill them. Focal length in terms of R. What is the mirror equation? What is magnification? So try to fill the blanks. What is refractive index? What is Snell's law? What is critical angle? What is lens maker's formula? See, we are trying to lift the entire topic in one shot here. So let us not. What is power of lens? So try to fill all these blanks. Okay, come on. So people on YouTube, do like, share the session so that most of your friends get benefited. We are putting lot of efforts and providing it for free. Come on, let us try to lift one topic at a time, as you are saying to speed up. Come on. Come on, we have tried to fill all these blanks. Third bench. Come on. Come on. You sit here. Come on, try to fill the formulas. So come on, let us try to fill the formulas. Come on, people watching online, come on. Focal length in terms of R. So what is the mirror equation? What is the mirror equation famous in terms of U and V? So what is magnification? What is refractive index? Not, I'm not asking value.
mu1 equal to 1 by mu2.
Speed of light in vacuum by speed in a medium. What is speed of light in vacuum? How do you represent it? How do you represent? Presented by c. Okay. So velocity in any medium is given as v, c by v. Okay, that's how you need to represent. So what is Snell's law? Sin I by sin r is equal to mu2 by mu1. Okay. See, it depends upon the refractive index of the medium, whether mu2 is 1 or not. Okay. So what is this critical angle in terms of okay, in terms of refractive index? What is this lens maker's formula?
1 by mu minus 1 into 1 by r1 minus 1 by r2.
Okay, what is this power of lens in terms of diopter?
1 by f plus 100 by f.
Okay, so these are the basic fundamental formulas. Okay, right. Come on, people watching online. Come on, people watching online. Check whether you are getting it right or wrong. So come on, try to focus on the subject. See, so come on. So now let us get back to a new topic, that is electricity and magnetism, famous electricity. We are done, you are late. Electricity and magnetism, which has a very great weightage in any competitive exam that you take. So you cannot take chance on this topic. So check whether you are getting it right or wrong. So people watching online, share it with your friends, like the session, and subscribe to our Roots Academy for further updates. Okay. So your likes really encourage us. So try to write the formulas of electricity and magnetism and check whether getting right or wrong. See here, U and V are the distance of the image and object. Miss Durga. See, these formulas are the basic fundamentals without which you cannot build any further equation. So you need to know, try to revise whether you are getting it right or wrong. Okay. So try to fill these blanks. Just a minute, once I am done. So once I complete it, I'll get back to you. Okay. See, try to fill these blanks. So try to fill these equations. Okay, come on. So people watching online, share the session, comment on the chat box. Miss Lata, that is not M1, M2. See, try to share the session so that your friends get benefited, okay? It is not for me. See, we are providing it for free because most of them get benefited. The only purpose is that the number of students getting benefit should be increased. That's our only objective. So come on, people watching online, try to like this session so that it really encourages us, because we are putting lot of efforts, and your likes will boost our energy and it provokes us to do as many free sessions as possible. It tells us whether you are so try to fill the blanks of all these. Okay, 1, 2, 3. We have 6 formulas. Complete them. So what is okay? What is electric field? Come on, come on, come on, come on. So what is electrostatic energy? See, people watching online, check whether getting or not. This is a beautiful chance for you to revise. So what is this Gauss law? Okay, similar thing. See, complete expansion of Gauss. Okay. So come on. Okay. So these are the basic fundamentals. Come on, people watching online, comment. Okay, try to convert it into formula, because in competitive exams. So Mr. Anuj, see we are trying to cover fundamentals, so minimum half in eamcet we can score because many questions are formula based in eamcet exam. So if you try to look at other exams, you cannot do any question without these formulas. So these formulas are very important for any exams that you are trying to pick, okay? So these are the basic fundamentals of electricity. Now let us try to look at capacitors. We'll follow. See, we are not done with electricity, right? Once we are done with electricity, we'll get into magnetism. See, we are trying to write the most important formulas so that you can get most benefit out of this session. We are not trying to cover entire concept. See, if you are thorough with these formulas, you can do a majority of questions in any competitive exams like JEE, mains, NEET, advanced, whatnot. Come on, people watching online, try to write formulas for all these and let's check whether we are getting it right or wrong at the end. See, come on, try to fill the blank. We have 8 questions. Yeah, you complete everything. We'll check. Come on, people watching online, comment. Yes, Inferno, you are doing right. You are great. You're doing good. Come on, Adhya, you are doing good. Okay, Miss Lata, definitely. We'll try to explain the problems as well. We are trying to cover the important concept first and problem session will follow. We have maths and chemistry sessions as well. So come on. So we are trying to put our best effort so that you get benefited most. So kindly encourage us with your likes. So do like this session and share this session. Subscribe to our Roots Academy for further updates. Hi Nikita, how are you? So your likes really encourage us. So do like this session and share. So fill these formulas.
Capacitance QS. Parallel plate capacitor C naught is equal to epsilon naught A by
Come on.
force between parallel plate capacitor
In terms of Q and A. Come on. So you can sit at this end. I guess there is lot of space, right? Is everything fine? Hope you are getting. Am I going too late or too fast? Come on, people watching online, try to comment on the chat box. See, these formulas are important for any competitive exam that you write, okay? Which exam are you going to write? When is your exam?
19.
Then come on.
కొన్ని క్వశ్చన్స్లో ఒక హాఫ్ థిక్నెస్ వరకు ఒక డైఎలక్ట్రిక్ పెట్టాం, ఇంకో హాఫ్ థిక్నెస్ ఓపెన్ ఉందంటారు కదా సార్.
Okay. I'll tell you.
దాని తర్వాత టూ సపరేట్గా కెపాసిటెన్సెస్ కనుక్కుంటాను సార్. దాని తర్వాత రెండు కాంబినేషన్ ప్యారలల్ ఉంటుందో సిరీస్ ఉంటుంది.
Question ఏమన్నా? Do you have any such question? So once you see, you send me. Okay? Come on, people watching online, try to share, try to comment. You can do it once this session is end, right? So come on. So people watching online, okay? So someone is asking that what is the rank that we get with 80 marks? So actually we will be having a guidance session. You will get to know from that. So no worries. Okay, Omkar, I guess you are doing. So come on, let's try to fill the blanks. So what is capacitance? Come on. Q by V, right? So, right? So, cylindrical. Okay. So, capacitors when connected in parallel, what is C equivalent? Come on, people. So come on, people watching online, do like the session, share the session, subscribe to our channel. You can get more updates. We have maths and chemistry sessions to follow. We have post guidance as well. So you don't miss the chance where you get knowledge for free. Okay. So like this session so that your likes really boost us and motivates us to do more number of sessions as such. Come on. So capacitors when connected in parallel, sum of all, okay. How about when connected in series? 1 by C equivalent is equal to 1 by C1 1 by C to right. So force between plates of parallel capacitor is equal to Q square by 2A epsilon naught. Okay. What is the energy stored? CV square by 2. Okay. You can replace C by Q by V and you can get different forms here. So capacitor with dielectric whose capacitance is, see, I'm trying to write the simplest form so that you can derive anything from here. Okay. So these are the basic things about electrostatics and capacitors. Now we are trying to get into current, electricity. Okay. Okay. Hope you have copied everything. Hope you are doing good. Come on. So people watching online, so come on, share the session so that many get benefited. Like the session. Huh? See, you don't want fan, right? No one wants fan. You want fan. See, okay, come on. See, just a matter of fan, okay? No worries. Come on, try to concentrate. See, we are, okay, hope you are done. So we are getting into current, electricity now. Come on, people watching online, try to write all formulas that you know about current, electricity and check whether you are getting it right or not. So like the session, share the session so that many get benefited. Come on, people watching online. See, V is the potential difference and A is the area, Miss Durga. V is the potential difference, A is the area. Come on. So try to write all the formulas that you know about current, electricity. What is J? Current density. Drift speed. Resistance. So famous Ohm's law. Kirchhoff's law. Resistors in parallel. Resistors in series. Wheatstone bridge. Come on, we have blanks, try to fill them. Come on, people watching online. Come on, Gautam. Hi, Adya, come on. Inferno, okay, you are doing good. Okay, Latha, come on. So please do like, share the session so that it really encourages us. We are putting lot of efforts and giving it to you for free. Okay, come on, Dream Chaser. So like the session, share the session. So come on, we have 7 to 8 formulas over here. Try to fill the gap. See, it's okay. Come on. See, there is much important thing going on. So please concentrate on that. You can look at others' book, right? Come on. Come on, come on. You have formulas to fill. I guess you hardly have 3 to 4 days time. And check whether you are getting it right or not. Fill them. When do you have exam? 19th, then you are supposed to fill, right? Okay, at least basic formulas. At least try to fill them. Come on, people online, please chat, please comment on. Okay, good. Okay, current density is represented by J. Okay, people are saying that they are done. How about you guys? Done, huh? 1 hour ago. Oh my God. What is current density? Come on, what is current density? I by A. See, what is density? What is general meaning of density? Mass by volume. Then why are you writing A here? See, density represents, it should be something like I by V, right? Why area? We basically talk in terms of area. So I by A, okay, right? Next. What is drift speed? See, there are different forms. So I'll try to write a couple of them here. What is resistance of a wire in terms of resistivity? Okay, rho L by A. What is Ohm's law? V equal to IR. What is Kirchhoff law? So try to, what is Kirchhoff law? What? Okay, that is one. The other part? See, sum of currents is at a node. This is at loop. See, this is sum of currents at node, sum of voltages in a loop. Okay? Come on. So, equivalent resistance when connected in parallel. Hmm. 1 by R equivalent is equal to correct, na? So how about in series? Tau. I guess it is some notation here even. So we'll get back to you, okay? You are aware of this, right? Okay, sure. So in series it is sum of two resistance. So what is this Wheatstone bridge? What is this? Something? Which coil? Galvanometer, okay. So what do we do with galvanometer? Okay, galvanometer is used to read current. Okay, what is voltmeter used for? Okay, what is ammeter used for? So difference between galvanometer and ammeter. Okay. Okay, 1 point. Still, what is the difference between galvanometer and ammeter? Why do we use two different instruments? Okay, people watching online, what is the difference between galvanometer and ammeter? Major fundamental difference. Come on, difference between galvanometer and ammeter. You better sit there, man, okay? There are many people, right? So what is the difference between galvanometer and ammeter? Come on. It's okay, you can. Come on. What is the difference between ammeter and galvanometer? Come on. Difference between ammeter, galvanometer. Measure. Yes, we have Rakshita here. She is right. See, that is one simple point. The points like, see, galvanometer not only just measures magnitude but also direction. Okay? Galvanometer gives direction as well, not just magnitude, whereas ammeter is just used to know the magnitude. Okay? So yes, we have good number of people replying. So Arvind, do you want me to explain terms as well? See, there are basic simple terms. I is current, A density, A area, R resistance, G for galvanometer, C, right? See, this is, so what is Wheatstone bridge? Okay. So these are basic fundamentals of electricity. So let us try to look at see, hope you got the difference between galvanometer and ammeter. Galvanometer not only magnitude but also direction. Ammeter only magnitude. Okay. Okay, galvanometer measures low current, but the significant difference is that it shows direction as well. So charging of capacitor. So now let us try to work out on formulas of charging of capacitor. Try to write the formulas with respect to time t. Discharging as well. Wait, what is Thomson effect? Come on. Thomson effect. Faraday's law of electricity. Come on. Try to fill in the blanks. What is Seebeck effect? Come on. Come on, come on. Fill in the blanks. Fill in the blanks. Come on, people watching online. So try to share the session. Okay, come on, TVSP, okay. Come on. People watching online, try to comment, like the session, share the session, subscribe to Roots Academy so that you get updates. From the we have maths and chemistry sessions to follow. Similar revision sessions will be carried and we are providing it for free. Come on, try to interact the session. So try to fill in the blanks. Come on, come on. Yeah, people watching online. Come on. Yes, please try to comment on. Come on, people watching online. So, so, so what is charging of capacitors QT? So how do you write them? So come on, let us try to fill this blank. QT CV in terms of 1 minus e power minus t by RC. What is QT discharging? QT is equal to come on. Yes, people watching online try to comment CV in terms of 1 minus e power minus t by RC, right? You better check. Okay, actually here it is given. Okay, sorry. Yes. Okay, so what is Thomson effect? EMF generated is equal to delta H by delta Q. This is nothing but heat by charge transferred. So what is Faraday's law of electrolysis? Faraday's law of electrolysis. Mass deposited is equal to 1 by F EIT. Where E is a chemical equivalent, F is value of F 96,500, right? If you try to approximate, where T is the time taken, I is the current, E is the chemical equivalent, okay? So what is this Seebeck effect? What do you mean by Seebeck effect? People watching online. Okay. So how do you try to tell in a sentence what is Seebeck effect? So people here are asking to speed up, okay? Come on. See, when there is it is not a coulomb, it's a number, constant, it's a constant. So what is Seebeck effect? See, when there is a temperature difference, it results in potential difference, okay? So they may ask you as a theory bit, like they will give you 4 options and they'll try to check whether you know or not. The temperature difference for certain metals leads to EMF difference, okay? So come on, let us try to move for magnetism. Okay, try to write the formulas that you know about magnetism. Come on, people watching online, try to share the session, like the session, so that many get benefited. Yeah, definitely, Mr. Sanjay. we are trying to cover all the basic fundamentals. So half questions in eamcet are based on fundamental equations. So as we are covering both in 2 sessions, so you can expect half questions, that is 20 questions, okay? You can directly expect these questions. So people watching online, share the session, do like it. So let us try to fill the blank of magnetisms. See, I'm trying to give conditions. See, it's okay, you move. See, come on. See, try to focus on something that is more important, okay? See, it's enough. See, magnetic field B bar. Let us consider a particle Q moving in a circle of radius R. Try to write the equation for R. Next, force on current carrying wire. Magnetic moment of a current loop. So try to fill the blanks. So people watching online, come on. Come on, people watching online, try to focus on things that are being taught. So try to share the session, like the session. So try to answer the questions given. So maths class will be followed, okay? Yes, Dream Chaser, you are doing good, come on. Comment your answers, make the session more interactive. So we are putting great efforts. So share the session so that many get benefited. See, you can expect question from this magnetism topic directly from any competitive exam. Come on. So try to fill that blank. See, what is radius? See, what is charged particle? Okay, what is the radius? mv by qb. What does q stand for? B? Magnetic field, okay. V? M? Mass. So what is that T stand for? What is T over there? What is T? What time? Time period. 2 pi m by qb. So force on current carrying wire placed in a magnetic field B bar. What is the formula for it? Okay, yes, Dream Chaser, you are correct. Time period of for one revolution. Okay, come on. People watching online, try to comment. Okay, still do like and share the session. Subscribe to Roots Academy for further updates. We have post examination session as well, which guides you to for a good college. Yes, Inferno maths class will be followed. Okay, you please be connected, you will get updates. So please try to comment. Okay. So force on current carrying wire, how do you write it? Okay. So magnetic movement of a current loop. Yes, Mr. Kodeshwar Rao, you can expect half of the questions because we are trying to cover the basic fundamentals. So no worries, just carry on with the session. So we are trying to talk about magnetic field. Magnetic field due to current. See, we are trying to write. So people watching online, try to fill in the blanks and check whether you are getting it right or wrong. This is field due to infinite straight wire. Okay. Force between parallel wires next. Force between parallel wires. Field on axis of a ring. Field on axis of ring. Come on, people watching online. So please do like and share the session. Try to comment in the chat box. Your likes really encourage us. and provoke us to do more number of sessions for free. We are putting lot of efforts. Subscribe to our channel so that you get more updates. So try to comment for the following blanks and check whether you are getting it right or wrong. So come on. So try to fill the following blanks. So people watching online, please comment the answers for the following blanks. Come on, try to fill the blanks. So let us try to fill the blanks now, okay? What is this Biot-Savart law? dB is equal to mu naught by 4 pi r cube. Okay, we are trying to write in the form of vector. Now field due to a straight conductor. So how do you write it? Hope you are aware of this cos theta 1 and cos theta 2. So what is this field due to a infinite straight wire? Mu naught I by 2 pi d. Okay, you can write it in the other way as well. So what is this force between parallel wires? Mu naught I1 I2 by
సార్ ఎక్స్క్యూజ్ మీ ఏమైందిరా ప్లాన్ గురించి ఏదో గొడవ అంట సార్ క్లాస్ జరుగుతుండగా ఎవరిని బయటకు పంపించొద్దు
C mu naught I1 I2 by 2 pi d. Field on axis of ring mu naught Ia square by Okay, hope you are okay with the notations. Do you want me to explain, or hope you are okay with notations? Come on, people watching online. Come on, people watching online. So, if you try to look at see if I want see this, I'm trying to represent theta 1 and theta 2 here, where d is the distance, okay, I is the current. So people watching online, hope you are getting my point. So the notations follow the similar way. I guess you hardly have any other new notation. Here A is the radius of ring. Okay. Let us try to move ahead. So people watching online, comment your answers and check whether you are getting them right or wrong. Okay, you can write in sin theta or cos theta. Okay, people are asking to speed up. Okay, let's try to speed up. So we have, let's try to look at Ampere's law. So try to fill in the blank. Formula for permeability. So we are getting into electromagnetic induction now. Okay. What is magnetic flux? Come on, people watching online, try to comment your answers in chat box and check whether you are getting them right or wrong. Faraday's law. What is EMF? Using the relation of electromagnetic induction. So self-inductance phi. Self-inductance of a solenoid. Come on, people watching online, comment. Okay, Dream Chaser, come on. Come on, try to comment your answers. So do like and share the session and subscribe to Roots Academy for further updates. We have maths and chemistry sessions to follow. Come on, let's make the session more interactive. Come on, people watching online, do it. Fill in the blank.
Sir, Faraday's which law? First law or second law?
Electromagnetic induction. Faraday's law of electromagnetic induction. Come on. So come on, people watching online, put your answers in your comment box. See, you can expect these questions in any competitive exam. So people watching online, come on, comment in the chat box. Okay, if you are answering good. Come on, people watching online, please do like and share the session, okay? Okay, people are asking to speed up. So what is this Ampere's law? Come on. See, what is this? Permeability. B bar is equal to mu H. Okay. So what do we have still? We have magnetic flux that belongs to electromagnetic induction, cyclic integral of, sorry, B bar dot ds bar. What is Faraday's law? EMF generated is equal to d phi by dt. What is phi here? Flux, rate of change of flux. So what is EMF? So what is B? See, here we are trying to take the simplest case, okay? So what is B, what is L, what is V? Okay, what is V? What? Which particle? Velocity of current carrying wire. So come on, okay, Sunita, you are right. Still, try to fill the, okay, inferno, okay, length. Come on. People watching online, do like, share, subscribe, so that it provokes us or motivates us to do many other sessions as such. So what is the self-inductance? $11:30, half. What is the self-inductance of a solenoid? Mu naught so self-inductance of a solenoid. So these are the basic fundamental formulas from so now let us try to look at the LR circuits, okay? LR, CR, LCR circuits, okay? So you can expect direct questions from these basic formulas. So first let us try to look at LR circuit, growth of current in LR circuit. See, you need to have these formulas on your fingertips. Decay of current, in LR circuit, time constant for LR, we are trying to talk about LR, energy stored in an inductor, so mutual inductance, so try to fill these formulas, okay? Come on, people watching online, try to comment. So do like, share the session. Come on, focus on things that are going here. So try to check whether you are getting them right or wrong. I guess this is the last chance to check. I'm giving you time as well. So please do like, share and comment the answers. Your likes really encourage us so that we can do more such free sessions. We are putting great efforts to make such sessions and we are providing it for free. Hope our efforts don't go ignored. So your likes really encourage us. Try to share the session so that many get benefited and subscribe the channel for further updates. There are maths and chemistry sessions to follow. So to stay motivated, the number of likes really acts as a booster. So come on, try to answer the questions given on the board. I know it's tough to write in chat box, but still you try to comment at least so that I'll get to know whether you are engaged or not. Okay, let us try to, Okay, let's try to speed up the process. So growth in LR circuit. Growth of current in LR circuit, I is equal to E by R 1 minus E by minus T by L by R. Okay, come on. So decay of current I is equal to I naught e power minus T by L by R. So time constant for LR circuit, L by R, okay. What is the energy stored in an inductor? Okay, half Li square. What is the mutual inductance? EMF generated due to mutual inductance? Minus M di by dt, right? Right? Now let us try to look at the AC current. So people watching online, sir, we have hardly 2 more topics left. So let us try to wind up the session. The one is the modern physics and the other is the communication systems, I guess. So once we are, yeah. So once we are done, we'll be closing this session. So come on, we are in AC circuit. Try to write the formulas you know about AC circuits. Inductive reactance, impedance, for RC, for LR and LCR. So try to fill the following blanks and check whether you are getting them right or wrong. So people watching online, come on. So very good morning, Anvesh. So try to comment your answers. I know it's tough to write all those e powers and all, but at least try to write something in words so that I will get to know whether you are engaged or not. Come on, people watching online, try to comment your answer, share the session so that many get benefited from this free session, and like as well so that it really motivates us to do many such sessions in future as well. So subscribe to Roots Academy so that you can get updates. So do like the session. Come on, come on. Come on. Come on, try to fill this impedance for RC, LCR, CR circuits, inductive resistance, RMS current, energy. Come on. So people watching online, try to comment on your chat box. So come on, I guess you have written. Okay, right. So people on YouTube are doing great, whatnot. So what is this RMS current? Okay, still any other forms of? See here I am trying to write the basic fundamental form so that you can, so it is I naught by root 2. This is first form, and if you try to write the basic form, it will be 1 by T integral 0 to t I square dt whole power half. Okay, what is the energy using the RMS current? IRMS square RT, right? Mr. Pink Shirt, phone's inside the pocket. What is the capacitive reactance? 1 by omega c, right? Okay, what is the inductive reactance? Just omega L, just omega L. So what is this impedance? Is nothing but V naught by I naught. Okay, so what is the value of Z for RC circuit? Under root R square plus 1 by omega c whole square. See, your XC stands for 1 by omega c, okay? XC nothing but 1 by omega c. So what is this LR? So what does XL stand for? What does that mean? Omega L here, right? So what is this LCR? Under root R square. Okay. What is XC? 1 by omega c, XL omega L, right? Now let us try to look at the power factor. Transformer. Try to fill these blanks. Come on, people watching on YouTube. Okay, Mr. Dream Chaser. Come on, do like, share this session so that it really encourages us. The basic reason that we are providing it for free is, okay, it's correct for transformer. So, like the session, it really boosts our energy. We are doing it for free. So, encourage us so that you can get more sessions as such. It is a great chance so that you can check whether you are getting it right or wrong. That is the reason I am giving time. So, try to write the formulas and check whether you get right or wrong. So what is this power factor in terms of IRMS, VRMS? Okay. So what is transformer? Now let's try to talk something about transformer. Why do we use transformer for? Before getting into the formula, so people watching online, try to comment what transformer is used for. Huh? Okay. Still. Hmm.
efficiency equal to 60%.
Okay. So one is to go from high to low, low to high voltage. Still any other uses apart from that? Hmm?
Correct to DC correct to AC correct.
See what is the concept involved in transformer? Hmm? Principle involved in transformer so that you can convert high voltage to low voltage. What is the principle involved? Mutual inductance. Yes, we are getting right answers. TVSP. Okay, good. So basically the types of transformer are step up and step down. So okay. So what is the formula involved with?
Ratio is NI NS by equal to IB by output power by input power equal to into.
So what is this speed of EM wave? Come on, people watching online. What is this speed of EM wave in vacuum? Try to write in terms of formula. That is speed of light. See, light is a form of electromagnetic wave. So electromagnetic wave consists of many other parts and light is one of them. So speed of light is 3 into 10 power 8. So I'm trying to ask speed of electromagnetic wave in a vacuum which has some properties like mu naught epsilon naught in terms of mu naught and epsilon naught. Right, 1 by under root. Right, 1 by under root mu naught epsilon naught. So these are the basic fundamentals. If you try to look at this, and let us try to go to modern physics. Now let us try to look at modern physics, and we will be closing the session within no time. I guess this will be the last topic. So try to write the formulas. So try to fill in these blanks. Come on, people watching online, try to fill those blanks and check whether you're getting it right or wrong. So come on, the photon's energy E from modern physics. Hc by lambda. Mr. Pink Shirt. What is photon's momentum? H by lambda. See, what is the maximum kinetic energy ejected of ejected photoelectron? H nu minus phi. What is this phi? Work function. What do you mean by work function? Threshold energy. The minimum energy required to eject a electron, right, from any given metal, and it is a property of a metal, right? So what is this de Broglie wavelength? H by, can also be written as H by P, where P is the momentum, right? So energy of nth Bohr orbit minus 13.6 z square by n square, right? What are the units of energy of nth Bohr orbit here? Okay, joules is one form, but here we are trying to talk in terms of volts, right? Electron volts. So radius of nth orbit. Okay, n square a naught by z. Okay. See, wavelength of emitted radiation from nth orbit to mth orbit. 1 by lambda is equal to, okay, r z square, okay, into 1 by n square minus 1 by m square, right? Okay, let's try to move ahead. Let's try to look at so before getting there, let us try to look at the other forms. Like we have, okay, chalo. So let us try to look at nuclear decay. Okay. Try to fill in the blank. Come on. So people watching online, try to comment your answers in the chat box. Do like the session, share the session. Okay. See, we are putting great efforts to cover the entire topic within 3 hours. So your likes really motivate us to do many such free sessions. Try to interact. It's not easy to write all those formulas in chat box, but at least put pen on paper and check whether you are getting them right or wrong. This is the last chance to check for you. So people watching online, try to comment the answers. Do like the session, share the session, and subscribe to Roots Academy. Okay. How about you guys? What is n? N naught e power. What is n naught? What is n naught here? Initial quantity. Initial quantity. What is n? At time t. Right. What is half-life? So ln2, value of ln2 by lambda, right? So what is average life? 1 by lambda, right? Okay, you can write anyway. So population after n half-lives. After n half-lives. What is the population after n half-lives? Okay, n naught by, right. See, these are basic fundamental equations. You can expect this question directly, like you can do within 10 seconds. If you don't know the formula, you will be missing. So come on, people on live. N is the number of amount present at time t. Okay, sorry. Where t is the time, right? Right. So n naught is the total amount present at time t equal to 0, and n is the amount present at time t equal to t. Okay. So people watching online, do share the session, like the session. It motivates us to do many such free sessions. So we are now at logic gates. Hope we are okay with logic gates. I guess this will become the last part. So we have A and B, or B, and or NAND, nor XOR. Try to fill this. Try to fill the column. People watching online, try to complete this. Yes, Mr. Dream Chaser, it's pretty easy and mark gaining chapter, so try to complete this box. So if you get wrong, you can check. So come on, we are about to end this session. So please do like this session, share this session, subscribe to our channel for further updates. We have maths and chemistry sessions to follow. So your likes really encourage us and motivate us to do further sessions. So please do like. So try to fill the box. Come on. Come on, try to fill the session. Fill the box. Come on, it's mark scoring topic. So people online try to fill the blanks, and once we are on board, let's check whether you are getting them right or wrong. Come on, people online try to fill. Shall we start? Come on, shall we start? Okay, yeah, they are telling that they are done. Okay, let's start. Okay, what is this AB? And 1, right? Okay. So that is opposite of and. Okay, what is this NOR? Which is opposite of OR. What is XOR? So if anything, any mistakes, check whether getting. Yeah, definitely you can expect questions from logic gate. So do like, share the session. Hope you got them right. So one final thing I just want to share you. You are getting theory questions from electromagnetic waves. Like they are trying to ask about the spectrum. See, wavelength, frequency. I guess you all know about this. So what is towards the extreme right hand? What do we have in the electromagnetic spectrum towards extreme right hand? See, we have radio waves where wavelength increases, highest will be for radio waves, okay? So your visible spectrum falls somewhere here, somewhere in between, okay? So it will be, so will red be towards right or left? Huh? Left or right? Will color red has the maximum wavelength or minimum wavelength? Wavelength minimum. Here you get red, here you get violet. So violet will have maximum wavelength. So sorry, I guess it is opposite. Yeah. Red will have maximum wavelength. Red will have maximum wavelength. Violet will have minimum wavelength. That is the reason red travels more distance. We use in traffic light and all, for danger symbol and all we use red light, okay? So red has the maximum wavelength. On the extreme left, what do we have? Gamma rays. Okay, extreme right radio waves, and the wavelength increases this way and frequency changes the opposite way. So these are the basic fundamentals if we try to cover the second year physics. So if you want to have a look at first year physics, please do watch the video which is in playlist done yesterday. As radio waves have longest wavelength and gamma rays have minimum wavelength, and VIBGYOR the visible spectrum falls and red color has a maximum wavelength. So do like and share this session, and we are trying to end session of today's class. If possible, we will be covering the other important concepts that are left behind in next session. Majority of them has been covered. So do follow the Roots Academy channel. So like this session, share the session so that many gets benefited and it keeps us to be motivated. So thank you. Yes, PDF will be provided in the description link. Okay, no worries. So thank you all. As communication system, okay, we will definitely do it. Due to time constraint, we are unable to do. Okay, I guess there are basic things you can cover. We are trying to cover major things here. So thank you all. Thank you for your valuable time. And please do like and share. Thank you. Thank you, Gayatri.